Hi there, 8th grade. Lesson 51, negative exponent scientific notation for small numbers. Okay? Objective, understand the law of exponents for negative exponent. Okay? Simplify expressions involving negative exponents. Use negative exponents to write very small numbers in scientific notation. Alright, at this point you can do power up. Then the problem solving under the power up. Okay, the reason I'm having you do that on this one, it's probably the first time all year we've done it, but I think it is very helpful. Okay, so the first one. Okay, so alright, negative exponents. We subtract the exponents when dividing exponential expressions that have the same base. Law of exponents to find the product negative exponents. So, as you can see here, we would subtract. When we subtract this, we're going to get x to the fifth divided by x to the third, which means that we just subtract our exponents, which then means we should end up with x to the second. When we do it here, you're going to end up with a -2, which actually can be rewrote. As you can see here, this is what that's talking about, is the fact that what if you have a negative exponent? Well, to make the exponent and just the exponent really positive, you kick the variable and the exponent to the bottom over 1. So this one would be 1x to the second. Now you can see why those two problems are different. Okay? Which of the following is not equal to 10 negative 3? Well, first off, we just got done talking about that first rule, in which case we're going to write it as 1 10 to the third. Well, this one works, so it's not that one that does not equal it. Okay? Now, what if we multiply it out? We're going to get 1 over 10 times 10 times 10, which is 1 over 1,000. Well, there would be. Alright, and out of the two we got left, if you remember the fact that we are technically dividing by 1,000, so if we're at 1 right here, we'd have to move 1, 2, 3. So it's not C, so our answer is D. D is the one that does not equal it. Alright, find each missing exponent. So on these, we're multiplying, so we add. What do we get when we take -2 plus -4? Should be a -6, so we have 10 to the -6. Here we are dividing, so we should subtract. We're going to subtract -2 minus a -4. Add by the opposite, we end up with a +2. Okay? And there's another way to figure that out, but not for today. You guys aren't quite old enough for that experiment. Alright, here we have our exponents, and they're a little bit different. This one we got to the -3rd. Well, how do I get the negative out of there? Well, I go put 1 and then I put 2 to the 3rd. I have to take the 2 to the bottom and bring the exponent only to be positive. So really we have 1 divided by 2 times 2 times 2, which is 1 over 8. Okay, here we have -2 technically, times -2 times -2. We will end up, when we multiply this, well, we'll get a positive 4 here, times a -2 again, we're going to get -8. That is my other option. There's my option 2. Okay. Once again, very, very similar to what we have been working on. We have 3x to the second times 3 -2. Okay, when we add this together, we're going to get 3 to the second minus 2. Well, it would actually be add -2, but that is going to be 3 to the 0. What is 3 to the 0? Well, anything to the 0 power is always going to be 1. So there is my answer for that one. All right. Now we got this long string of stuff going on. All right. We only have one regular number, or constant. That is 2. I'm going to put that there. All right. Now we look at my x's. I have a -1 and a 2. If we add those together, we're going to get x to the first. Okay, so that's gone, and that's gone. So that leaves me with y and y to the second. We're going to add exponents again. We get y to the third, gone, and z. There is my answer for that one. All right, another problem. This one's just full of things. All right. So I'll write this in standard form. Okay? So the one thing this tells me is I got to move my decimal 3 places to the left. 1, 2, 3. Here you're going to get 0.0015. That is my answer there. All right, now we're going to go back the opposite way. Now it's wrote as a decimal. Now we're going to write it in scientific notation. We had to move it to the right. 1, 2, 3, 4, 5, 6. So we got 7 times 10 to the -6. So we got to make it smaller. And if we divide by a bigger number on the bottom, as you can recall, and that's what happens when we usually do a power, this number is going to get smaller and smaller and smaller every time we add a 0. So I think we did that correctly. I believe would be what I'm trying to get at right there. All right, we have to compare these. Okay, we have -10. All right, this is a good one. All right, so we got 1 sitting here. We got to move it 1, 2, 3, 4, 5, 6, 7, 8. Too far. All right, 1, 2, 3, 4, 5, 6. 0, 0, 0, 0, 0. Which side is larger? Well, this isn't a negative number. It's really, really small, but it hasn't been negative yet. So I would have something that looks like that. Interesting concept. All right, time to do your practice set. Like I said, if you're not in school, you feel very unconfident about yourself, come and check with me on the practice set. Obviously, I want to make sure you understood today's lesson. If you had any questions on the homework, also come and see me. There is your homework.